Hello and welcome to this new series, an introduction to the world of batteries. I propose to make this series in four parts. It is mainly meant for students, but also useful for employees who are joining the battery industry and who are not familiar with the subject of batteries. So, welcome to this new series where part one will be presented today. So we have series one, part one, and let's proceed. This slide outlines the topics on which I will be speaking. In the first part of the series, I will provide an introduction to lead acid batteries, including a brief history of the technology, subsequent developments, and the various applications of lead acid batteries in different fields. In parts 2, 3, and 4, I will cover the other 6 topics which are mentioned in this slide. As I discussed earlier, there are 4 topics highlighted in red that I will cover in part 1 today. Let us now understand the two major types of batteries. We have the primary batteries and the secondary batteries. Primary batteries are the type of batteries that we generally use, and once they are consumed, we discard them. These are the batteries used in TV remotes, air conditioner remotes, and toys. They are small batteries that are consumed of their energy, and once this energy is depleted, they need to be disposed of. Secondary batteries are batteries that can be used, recharged, reused, and recharged again for a certain number of cycles as defined by the battery manufacturer. The lifespan in years or the number of cycles that a battery is expected to last is of course dependent on the application of the battery. Batteries are designed specifically by a battery manufacturer based on their respective applications. Lead acid batteries are secondary batteries, an electrochemical device that converts chemical energy to electrical energy through a reversible reaction. Lead acid batteries have been around for over 160 years, and although it's an old technology, lead acid batteries are very reliable as an energy storage device. They are used in many applications, and I will be explaining them in detail as we proceed further. Now, let me explain precisely what happens when the chemical reaction occurs. We have a group of positive plates and a group of negative plates inside a battery cell. Now, these positive plates and the negative groups of plates are immersed in a dilute solution of sulfuric acid. These are then charged. In the charged condition, the positive electrode is lead dioxide and the negative electrode is sponge lead. Hence, there is a potential difference between the PbO2 and the Pb, which is the reason why the current flows. When it comes to the acid, dilute sulfuric acid is the electrolyte. The specific gravity of this acid rises as the battery gets charged. Now, why does this happen? This happens because the sulfate from the plates that have been put on charge is going into the electrolyte. So when lead sulfate becomes PbO2, the sulfate enters the electrolyte, and in the case of negative, when the lead sulfate becomes sponge lead, the sulfate enters the electrolyte. The electrolyte specific gravity naturally increases. However, when this battery is discharged, the PbO2 becomes lead sulfate, and that is in the case of the positives, and in the case of negative, the Pb becomes lead sulfate. The acid specific gravity becomes low, and the electrolyte is thus very dilute compared to earlier. Thus, when both the positive and negative plates are forming lead sulfate, the acid becomes very dilute. Consequently, in a discharge condition, when you check the specific gravity of the acid using a hydrometer, you find that the specific gravity has fallen or is very low when the battery is in a discharge condition. I shall now explain the history of lead acid batteries in brief. I need not go into much detail because I have already written it down and it is very clear. Gaston Plante invented the batteries in 1860. He did this by immersing lead foils in sulfuric acid. In 1881, Faure coated these lead foils with lead oxide paste. The lead foils became the conductor and the lead oxide paste became the active material. In the same year, Ceylon introduced lead antimony grids. Instead of very soft lead foils, the lead antimony grids were a bit harder because antimony imparts hardness to lead. In 1881, Volkmar introduced perforated plates, creating space for the lead oxide paste. And in the very next year, that is in 1882, Brush worked on mechanically bonding lead oxide to lead plates. Gladstone and Trim developed the double sulfate theory of reaction in lead acid batteries in 1882. Tudor made a paste of lead oxide in 1883 and applied it to a grid that had been pre-treated with the Plante process. Lucas then worked on the formation process of lead plates in 1886. In the case of formation, what happens is that, as I mentioned, the lead sulfate of the positive plates become PbO2 by oxidation and the lead sulfate of the negative plate get reduced to sponge lead by the process of reduction. This is a simultaneous reaction known as a redox reaction. Until now, these were all pasted plates where both positives and negatives were pasted. However, when you cycle such batteries having pasted plates, we realize that the positive active material sheds off. Hence, in 1890, Phillips invented tubular plate batteries. This was done to extend the battery's life. Woodward in the same year 1890 further processed these and worked to improve the tubular plates. In 1910, Smith introduced the slotted rubber tube or Exide tubular structure to further improve tubular plate technology. And after that, when it was realized that the antimony in the alloy was creating a problem in terms of a requirement of frequent topping up, they wanted an alloy that would require less topping up. So Herring and Thomas created the lead calcium alloy. This is the alloy widely used today to manufacture the popular type of sealed maintenance-free batteries. In 1935, Hammer and Harned established experimental proof of the double sulfate theory of reaction. And in the subsequent years, a lot of people worked on the active material of the plates and clarified the characteristics of alpha and beta PbO2. I must mention here that the source of all this historical data is the Handbook of Batteries and Fuel Cells, a widely referred to, well-authored book thanks to David Linden. Subsequently, numerous developments have been made. These developments were necessary because the volumes increased as the requirements for batteries became more. Automation was the way out to increase production and productivity. This was also an opportunity to save costs. It was tough to make batteries by following a process that was quite cumbersome. Initially, we had these hard rubber batteries with individual cell covers. The gap between the container and cover used to be filled with bitumen. However, this was not only time consuming, but the entire battery was also bulky. To make cars more fuel efficient, the automobiles had to become lighter. Automobile manufacturers requested that battery manufacturers produce lighter batteries. Hence, battery manufacturers shifted to polypropylene containers, which were lighter and thinner walled than the previous containers. But now, how do they seal the container and cover it? They did not want to put bitumen. They realized that it is possible to heat seal it. The heat sealing of batteries and PP containers with covers began. Once this was done, the connectors which were used in the earlier cases that had above the covers container arrangement, these were discarded. Here the connectors were routed through the partition of the battery container, and therefore inter-partition welding was performed. This is a spot welding operation carried out, and this also reduced the size and weight of the lead component used to make the connectors. Naturally, with lead less being used, the cost of connectors also reduced. PVC separators were initially used. However, they proved to be quite brittle and lacked the resistance for high temperature operations. They used to get damaged, and there were some cases of internal shorting. Over time, polyethylene separators were introduced, which were flexible, more heat resistant, and also had a lower internal resistance. Subsequently, lead calcium alloys intended for suitable, the sealed maintenance-free batteries were introduced. Now, these were not particularly easy to use for all the battery manufacturers. Manufacturers producing normal flooded electrolyte batteries continued to use the antimonial lead alloy. However, they also wanted to address the issue of water topping up frequency in terms of maintenance. The introduction of lead selenium alloy solved the problem of water topping up frequency. The development of this alloy enabled the reduction of the antimony content in the alloy. The water topping up frequency decreased as a new alloy was introduced as the lead antimony selenium alloy. The sealed maintenance-free batteries, which used lead calcium alloys, required separators that could hold the electrolyte. AGM separators were introduced. AGM means absorptive glass mat. The electrolyte is trapped in these AGM separators, which are like a sponge. This development enabled the battery to be kept in any orientation with no electrolyte flowing out. There was another maintenance-free battery that used a gel and mixed sulfuric acid with certain silica and other additives. The gel electrolyte batteries are also maintenance-free. Thus, we have maintenance-free batteries of both the AGM and gel types. Subsequently, glass fiber separators were also introduced. The glass fiber separators were introduced for use in conjunction with polyethylene separators for low maintenance pasted plate batteries. As time progressed, chemical additives to the paste were developed that could improve both the life and performance of the battery. Now, curing was one area in the process of plate making which was cumbersome and also mysterious in a way. The introduction of tetra elemental seed crystals helped with better and faster curing. Charging was another area where the carbon nanostructures were introduced for better charge acceptance. Let's now see the next slide, which presents a few more developments from the last few years. Batteries such as those used in material handling equipment or golf carts require frequent topping up with water. These batteries had to be made using high antimony in the alloy because they were used for cycling applications. These batteries are charged and used daily after being discharged regularly. They are charged overnight for use the next day. In these cases, water topping up is required more frequently compared to an automotive or stationary battery. This was often neglected by the customer, resulting in battery damage and reduced lifespan. To tide over this problem, automatic water top-up systems were introduced to reduce the maintenance activity. Another introduction that was made was recombination vent plugs with a special catalyst, but this did not gain much traction due to cost reasons. The addition of carbon nanotubes to the paste material for improved capacity and lifespan has also been introduced and has gained considerable acceptance. To make the process of battery manufacture easier, considering the increasing volumes, computer-controlled charging systems with a data logging facility were another development that has taken place in the battery industry. Subsequently, expanded and punched metal grid technology was adopted by large battery manufacturers, which required high volumes of production. Development of efficient pulse charging equipment was also undertaken to accelerate the charging process. Considering the tightening of environmental regulations worldwide, efficient air pollution and effluent treatment plants were also developed. I shall now explain the various applications of batteries. As I mentioned at the beginning of the presentation, there are two types of batteries, primary and secondary. We shall be discussing secondary batteries only. When it comes to secondary batteries, there are various types, including lead acid, nickel cadmium, zinc silver oxide, nickel ion, sodium ion, and lithium ion. Sodium ion has not yet been commercialized on a large scale. Lead acid is a proven technology, while lithium ion is an advanced cell chemistry that is gaining popularity and catching up. Lithium ion batteries were initially used for small applications such as mobile phones, medical devices, digital cameras, portable tools, and toys. However, it was subsequently found that their main purpose and primary advantages emerged when they were used in electric vehicles. Subsequently, lithium-ion batteries have also been used in solar plants, data centers, and home UPS inverter systems. Recently, they have been making their presence felt in another area, which is the material handling vehicle area where traction batteries are used. They are used in forklift trucks, pallet trucks, platform trucks, and all battery operated vehicles that are used in industries. Returning to our subject of lead acid batteries, we have two significant areas of use. One is automotive and the other is industrial. In the automotive industry, of course, these batteries are used in two-wheelers, three-wheelers, cars, buses, trucks, and also for genset starting. These batteries in the automotive segment are also classified as SLI batteries, which are starting, lighting, and ignition batteries for ICE vehicles, that is, internal combustion engine vehicles. Most people are aware of lead acid batteries used in automotive applications, but a large number of lead acid batteries are also used in industrial applications. When it comes to industrial applications, there are three main segments. One is the stationary or standby batteries. The second is the traction batteries used in material handling equipment. And the third segment is semi-traction batteries. Let's see how stationary batteries are used and where they are specifically applied. Stationary batteries are used in telephone exchanges, electricity substations, large UPS systems, and power stations. We have a large number of batteries used in railways for signaling and telecom applications. They are called stationary batteries because they are fixed in one place and used in a specific location. They are not mobile. In stationary applications, the batteries are kept in standby mode and are used only in the event of a power outage or an emergency shutdown of the power supply. These batteries get recharged when utility power resumes after a shutdown. Stationary batteries are also used for renewable energy, especially in solar photovoltaic systems. The batteries used in solar photovoltaic systems are a type of cyclic battery rather than a pure standby stationary battery. These batteries are charged during the daytime using solar energy from solar panels and they are discharged at night. Batteries are also used in railways for train lighting, locomotive engine starting, and air conditioning applications. When it comes to semi-traction batteries, which are another area under the industrial lead acid battery segment, these batteries are used in golf carts, toy trains, scrubbers, sweepers, wheelchairs, and electric vehicles. There is no other fuel used in golf carts, toy trains, scrubbers, sweepers, wheelchairs, or electric cars. Of course, many electric vehicles have now shifted to lithium-ion batteries. However, some still run on lead-acid batteries. The primary power source for these vehicles is the battery. It is moved using battery power. Another type of industrial battery is the traction battery, which is used in material handling vehicles. Material handling vehicles are primarily forklifts, platform trucks, pallet trucks, and some electric vehicles used within the industry. There are numerous warehouses and large organizations where a significant amount of loading, shifting, or storage in massive warehouses needs to be done. And the movement of heavy materials is facilitated using forklifts, platform trucks, or pallet trucks that run on batteries. I hope that explains the various applications of the lead acid battery. Here I am visually illustrating the applications. As you can see in the top left corner, there is a UPS or an inverter that is used to power a home. When the power from the utility is shut down or fails, the inverter or UPS draws current from the battery to power the load. In the top middle, you see a house with a full roof covered by solar panels. In many cases, especially in remote areas, solar panels are used to charge the batteries, which in turn power the various equipment and appliances. In remote places, there is no utility power, and the only power available is through batteries. We have another picture on the top right where you see a motorcycle for which the battery supplies the starting, lighting, and ignition power. Similarly, the engine of the car which has been shown on the bottom left is started using a lead acid battery. You can see a forklift truck which is used in warehouses and large industries to transfer materials, either kept on a pallet or a platform. These materials are then relocated and moved from one place to another using the battery operated forklift. The last picture at the bottom right is of a golf cart used on a golf course, which also runs on batteries. In this slide, I've just shown you the various types of motorcycle batteries. Now, this is an automotive battery. This is a small size battery used in a car where the automotive battery's positives and negatives are of the pasted type. I mean, the plates used for making the positive and negatives are of the pasted type. This is an inverter battery. Here the positives are tubular in construction and the negatives are of the pasted type. These inverter batteries are the ones we use at home to power our appliances, lights and fans when the power is not available from the utility source. These are 2-volt cells in transparent containers. They are used extensively in large UPS systems. In many industries, we have continuous processes and we do not want the power to go off even for a moment. If the power fails, we do not want the machines to stop working as the losses incurred in continuous process industry run into thousands of rupees and even lakhs of rupees. In such cases, large UPS systems draw power from these batteries, convert the DC power to AC power, and supply it to the load. So these are 2-volt cells connected to large UPS systems. The batteries are connected in series with voltages ranging from 230 to 360 or even 420 volts. Now, similar battery cells in transparent containers with some design and formulation changes are also used in solar photovoltaic systems. So these are a few 2-volt cells manufactured in PP containers connected in series and used for solar photovoltaic systems. These are semi-traction batteries used for golf cart, scrubbers, sweepers, and wheelchairs. This is a traction battery. These are huge batteries. They are cumbersome to handle and used for material handling applications. They also act as a counterweight in the forklifts, and these are also used for platform trucks and pallet trucks. You may have seen luggage being transported from the aircraft to the airport terminal using vehicles that operate with motive power traction batteries. Many traction batteries are used in the food and pharmaceutical industries because these factories do not permit the use of diesel or petrol vehicles. The smoke emitted by the engines can settle on food or medicine, contaminating it. In such cases, lead acid batteries are used and forklifts running on batteries are allowed to move inside the factories. For more details, you can follow me on LinkedIn and YouTube. I also have a WhatsApp community and an email community. Members of this community receive regular updates on the various activities that I undertake. To join this community, please visit my website www.rameshnatrajan.in and contact me by sending me an email. You can also read my articles on Medium and Substack. If you're interested in learning more details, I have authored 3 books in English as well as one in Hindi. These are all available on Amazon, Flipkart, and Notion Press. Thank you for listening, and I hope this session, which was part 1 of the series on Introduction to Batteries, was helpful. Please await part 2 of this series, and thank you once again.